Okay. Let's take a quick look at exorcism. Let me bring it back up. Here we go. Okay, let me log in. I logged out? Let's see what we got here. I don't know. Getting logged out now and then. I guess it happens. For some reason, is my sound weird? Let me just see. Um, Let me just see what it sounds like here. Oh, that sounds fine. Okay, cool. All right. So let's knock some more of these out. We're getting close. We're getting quite close to the end of the year, and I believe I've completed over 100 now. So you know what? Yacht. I don't know what yacht is. Let's take a look. Common Lisp yacht. Let's try it. Okay, so let's open this up. And we'll see what happens. It said something about a dice game, right? In fact, I can kind of see it. You can kind of see it. Okay, so let's go to Exorcism. And we're in Common Lisp now, it looks like, and Yacht. All right, let's see what it's about. Look at the icon they use for Lisp. What the heck? It's not even an icon. It's literally just parentheses, I guess. That's weird. All right, so what's the README? So it would seem that something new is all the rage in your high school. This year it is a dice game, Yacht. The game of Yacht is from the same family as poker dice Generala, and particularly Yahtzee, of which it is a precursor. The game consists of 12 rounds. In each, 5 dice are rolled, and the player chooses one of 12 categories. The chosen category is then used to score the throw of the dice. Okay. Given 5 dice in a category, calculate the score of the dice for that category. You'll always be presented with 5 dice. Each dice's value will be between 1 and 6 inclusively. The dice may be unordered. Okay, interesting. So, and then here are the scores. So if we look in our source code stub, what have we got there in our stub file? It says def package yacht, okay. And then a score comes in, and there will be scores and a category. So I guess these scores are a list of numbers, right? I think. And then the category is, I guess, probably a string, right? Okay, so here's the explanation, I guess. So now, let's put that table into the file so that we've kind of got it, right? Okay, so then Common Lisp comment. Okay, I'm not spelling well. This is not going well. But sure, so we put 3 semicolons apparently. Okay, that's fine, I guess. So let's go. Did I see something there? Oh, I never opened my manager screen. Let me open it. All right, it's open now. Okay, so now where was I? So okay, so we have this, but I think all we really need is that table, right? Scores in yacht table. Okay, so we have these 12 categories. If the dice do not satisfy the requirements of a category, the score is 0. If, for example, 4 of a kind is entered in the yacht category, 0 points are scored. A yacht scores 0 if entered in the full house category. Okay. Okay. All right. Interesting. So, I guess we're going to kind of switch on the categories, but it might just be like if, right? In fact, let's say it's if, and then let's say equals category, and then let's put the first one in, so that's going to be ones. All right. And then we'll have a then and an else, and in the else, I will say if again. Okay, I'm just going to do it this way. Why not? Uh-oh, what have I got here? 2 notification. Let me see what it says. PogChamp. Oh, I have a Twitch recap. All right. I'm not looking at that right now then. But that's what the notification is for, a Twitch recap. Okay, that's fine. All right, so there, let me put these at the same indentation level and this one over there. Okay, so if category is 2s, right? Then we have something. Okay. All right, so 1s, 2s, I think I put too many. 3s. Let's see what we've got again here. 4s. 5s. 6s, full house. Big straight. Yacht. Looks like this one is extra. And then if we look for 2s, this one is going to be 6s. This one will be little straight. And this one will be choice. Okay. Interesting. So is that 12 like we think? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's only 11. Didn't they say 12? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which one did I miss? Oh, I missed 4 of a kind. Oh, goodness. Okay, well, that's weird. But yeah, let's put it in. 4 of a kind. All right, so we've got these different categories. Now, I think so I think what I've missed here is the closing for all the various ifs, right? So this one is closing here. So we'll close this one, 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 and this one. So that's how it's gonna be, all right? That's how it's gonna be, I guess. Okay, so now we're going to return the score. So I think I'm gonna put the different scores into different functions. So I'm gonna put dfun, and this is gonna be nums score, and it just takes scores. All right, and then we're going to, I guess, fold. Yeah, is that what we're doing? Folding? Okay, so now, let's see, is there an LSP? Let's see, CLLSP, excuse me, CLLSP, there we go. This is a good jam, but I actually do feel that this one is out of place on my playlist. Like, every time it comes up, it distracts me a little bit. So I am going to list this one as coming off the playlist at some point. So the song is Lost Woods Symphony Remix. Lost Woods. I'm just going to put Lost Woods. I think it's the only Lost Woods. All right. So apparently we're trying to install, but it seems a little slowish. perhaps just a little slowish. Should we look at anything else while it does whatever it is that it's doing? I'm hoping for some help, like that it'll tell me built-in functions like fold. Oh yeah, let's look at that. Common Lisp fold. Here it is on Wikipedia. Lisp. Okay, so we can do fold R. Interesting, interesting. So this colon is like an ident. Wait a minute. Shallow copy. Common Lisp. Oh, okay. Hey, this is nice. Whoa, this is good. Wikipedia is often very good in my opinion. So let's take a closer look here. All right, so here we have in various languages this extremely useful function, right? And one nice thing is that many of these languages have been covered in 48 and 24. APL was not. They don't have APL on Exorcism as of yet. But anyway, so we're looking at Common Lisp. Okay, so here's what it says. So we can do left fold, reduce. We can do right fold if we put from end here and put a T, I guess. Left fold without initial value. That one looks easy, right? I believe we do need an initial value though for ours. So we'll do this. This looks very nice, right? I love this table. So we don't have something for unfold. Ah, interesting. So in F# and Gleam, we have unfold options. Huh, that's cool. What's this one? Haskell. We have unfold in Haskell. Okay. And then what's this last one? Notes. Yeah, what notes do we have on Common Lisp? This is a delightful table. This is really cool. There's no notes for the Common Lisp. Okay. Gosu. Huh. I don't recall having ever heard of this or seen this. Interesting. Very cool. Here, yeah, there are several here, like log talk. I don't think I've ever heard of log talk. Leverages the Prolog language. Whoa. Maple, I'm pretty sure I haven't heard of this. Symbolic and numeric computing environment, as well as a multi-paradigm programming language. Sounds like a beast, huh? It comes from 1982. All right, so are we done over here in Vim? We should be by now. No, it's still compilation unit aborted. Okay, I'm gonna abandon it then. Forget it. Forget it. All right, we don't need it. Wikipedia already gave me the help I need. So we are going to do defun. Okay, so now in this part, we are going to reduce. Okay. And then let me look back at what Wikipedia said for Common Lisp. So it says we are going to reduce. We have to put a func here. All right. Okay, so I think I will define that func separately. Oh, you know what? The func should be passed in here. Yeah, okay. Probably. Sure, let's pass the func in. That I think that'll make it a little easier. So then we'll reduce, we'll put the func, we'll put the scores, and then it says initial value. All right, and then for that I will put 0. Okay, so that should be it there, I guess. Okay, so now so this is going to be a little bit verbose, which is what I tend to do when it comes to these Lisp challenges, just because I'm trying to get stuff done and I don't understand Lisp very well. So here we go. So one's func will take a num, all right? Well, it'll take an ac and a num, right? There we go. It'll take an ac and a num, we think. Oh, do we know? So the func in Common Lisp. Let's look it up again. Common Lisp reduce. We just want to make sure, like, does the ac come first, or does the num come first, or what? So this is reduce. Might be called with either 0 or 2 arguments. Okay. And so here they used a multiply, and here they used a plus, it looks like. So these seem cool. Uses a binary operation function to combine the elements. The function must accept must accept as arguments 2 elements of sequence or the results from combining those elements. The function must also be able to accept no arguments. If key is supplied, it is used to extract the values to reduce. So we didn't do key. Reduce function append subtract in short, I think it is ac first, but we'll find out. Okay, let's go back to our Vim. Okay, so ac num, and then we'll say, so now we have to say what it was here, right? Let me just go ahead and move this up. Okay, so 1 times number of 1s. So here it's easy. We just go plus ac num, right? So probably we could just use something like a plus, I don't know, but I'm just going to do it this way for now. Okay, so let's get the 2's. Okay, so defun 2's func ac num. So then this one is going to be plus ac, but now we multiply by 2, right? No, this is not right at all. I have not done this right at all. Not even close. So, let's delete. So it's actually if, okay, and then we say equals num1. Okay, this makes more sense. Then it is ac plus 1. Otherwise, it's just ac. All right? That's the way it is, I think. All right. So then this one, if equals num2 ac plus 2 ac, right? So they're going to be very similar like this. Okay, so for 3's func, we're going to say 3. Oh, interesting. So since they're so similar, let's go ahead and just define a higher order function that we can get these functions from. So let's just say defun n func, right? Common Lisp return function. No, not returning a value from a function. Maybe more like this, yeah. Returning functions. So here, oh, they used lambda. Okay, well that works for me. Let's see what it says. Okay, so common Lisp lambda. This seems very important, right? A lambda expression is a list with the following syntax. Lambda. Okay, so it's very similar, I guess, to defun. And then where did they use lambda here? Well, they didn't do any that returned a lambda per se, but yeah, so we'll say we're gonna take ac num n, all right, and then we'll do a lambda, okay, and that is ac num, and then we'll say if equals num n. Okay, so my bad. This one just takes n and not those other two. There we go. Okay, so now if equals num n, there we go. Ac plus n, else ac. Okay. So let's see what we get. So in here, we've got ones. So now let's try saying nums score. All right, so now we're going to reduce. We are going to put in scores. And then this part is going to be n, no. This part is going to be n func 1. Have I missed anything? That actually seems really nice. I actually am happy about that. Okay, so then it's going to be same idea for these others, I guess, right? Nums score scores n func 2, right? So now we just do 3 here, 4, 5, 6. I feel like I feel like I have probably missed something, but I don't know. Let's see what happens when we test. Oh no. Okay, let's see what the help says. To run the test, we are supposed to do what? Um, oh, okay. Yes. This should be all right. So we're gonna load exercise test. Okay, so common Lisp REPL. Did I use it before? I think I must have, right? Common Lisp. It was a while ago though, by now. I've been at this for a while. It's actually kind of crazy. So, yeah, here was the hello world in Common Lisp. I had a if operator here, I guess. Okay, I think this told us how to do the REPL, right? Was it Roswell? Ros. Ah, okay. Ros run. Oh, interesting. So this one is load. Here, let's go over to raindrops real quick. Raw, yeah, so did that run the tests? Oh, interesting. Okay, so now let's go back to yacht. Okay, so raws run load. Okay, so this time it's gonna be yacht test list. All right. And then what did we say next? We said eval, right? Okay, so eval, and then we put in this short Lisp code expression. So we're like UIOP quit, sure, and then if, all right, yacht test, I guess, run tests. Then I have a 0, 1, and those are for the... Oh, interesting. Oh, okay, okay. Okay, that seems fine. Okay, so let's see. 0, 1. I don't know if it's going to be the same, but let's try running the same. Oh, interesting. Cool. Cool, cool, cool. 29 checks. That seems like a good amount. All right, so caught style warning. The variable ac is defined but never used. Okay. I guess I screwed up the ac. I very probably did. So the ac is supposed to be here and then used here, right? This is where it's meant to be used. So what do you mean never used? Is it, well, it's... Oh, shoot. I think I probably did the lambda wrong. Let's look again. Let me just look at one of the examples. Okay, so lambda. Seems like that should have maybe been okay. So... Okay. Well, it wasn't. It wasn't. We had various problems. Let me do it again. Okay, so here's our test output. So none of it worked, and so the ac is defined but never used. Okay, so that's definitely not intended. So we have lambda, we have ac here, and then ac here and here. Undefined function ac. Oh no. Oh no. So here is it true? Oh, it is. It is actually. Yes. I had forgotten about that. So we can't have parentheses here because here it thinks it's a function. Whoops. It has to be like that. Okay, is that any better? It should be a little better, I think. So let's try raws again. So now Lots of output still. Uh-oh, it does still say undefined function yacht act, so that's not good. And it says undefined function act here, so that's not good. Constant ones conflicts with its asserted type number. Its asserted type number? Let me take a look at this one first. So defund the score equals yachts category ones. Ones conflicts with its asserted type number. Okay, so I need to take a quick look at the test. So in the test, they put in a colon yacht, it looks like, for the category. Okay, so it's not at all what I thought. But it's an easy one to change. So let's change it. So I put ones as a string here, but this is not at all what we want. Okay, so we want this. For full house, did they put a dash in it? I'm guessing dash, but we'll look right after this. H. Okay, so now in the test again. Okay, so yacht. Okay, and they did use dashes. Okay, so that was good. Cool. So now let's run raws again. Still lots of outputs, still no passes. Still most of these the same, I think. But I believe we took... No. This is still what we saw before as well. Ones conflicts with its asserted type number. Okay, so I think what we've done is we've done an equals, right? So if equals yacht category ones. So now in Lisp, symbol equality? Okay, so we want, oh wow, okay. Various equality functions. This looks like a great place to look. Lisp cookbook. Okay, equals is for numbers, so that's what we discovered. Kind of the hard way, I guess. But yeah, so we can't use that. EQ is low level. Okay, which one is for symbols? Strings. Null. Equal. char equal, tree equal. Oh, okay, cool. So we don't want this. Do we want EQ? Ah, use EQ for symbols and keywords. Excellent, excellent. So this should be that, right? This should be equals because it is a number. Okay, cool. Awesome. That's very interesting. I like it. So let's clear again. And presumably we probably cleared up something, but I don't know if anything will pass. Let's see. Oh, 2 did pass. Okay, that's a start. So here, undefined function yacht ack, so that's still messed up. That's really not good. So this is for sure a problem. We've said nfunc yacht ack plus yacht n. Defun ack n. Huh. Let me look again. Did I miss something ridiculous? Okay, so I've defun n lambda ack num if equals num n. Oh, that was careless. Okay, that might help. So let's do it again. Raws, baby, raws. Okay, so lots didn't work. 9 passed now, so that's progress. And I think this message is fine, so that's good. Okay, so now test 1 has failed. So let's look at what is test 1. Test 1 is... Okay, so the first 2 tests are for the yacht, and we haven't done that one yet. And in fact, I think that's going to be the last one I do. So these are good. I'm pretty happy with this part. Now, so we did these. The next one to do is full house. All right. So 3 of, okay, this gets a little more complicated, doesn't it? Interesting. Interesting. Okay. So as I'm looking at this, I notice some are easier than others. I want to knock out the next easiest one. It looks like is choice, right? So for choice, we should be able to actually just put, I think, reduce, right? And then for func, I'm going to put lambda. Let's see how this goes. And it's going to be acnum. Wait a minute. This is not right. For func, I just actually want to put plus. Yeah. It's actually that simple, isn't it? And then initial... We don't even need initial value in this case, right? I think it's literally just that. Oh, I put it in the wrong place, though. That's for choice. Okay, let's see. Okay. XX. Common Lisp nil is undefined. Oh, it still says 9. So did we not pass choice? Let's see. Big straight, little straight. These are all the ones that failed, right? Oh, I don't see choice amongst the ones that failed, I don't think. Unless it's one of these. Function common Lisp nil is undefined. 29 and 28. Oh, this is choice right here. Okay, so 28 and 29 failed, and it said something about nil. I'm not sure what I messed up. So I tried to just put reduce plus scores, but that wasn't it. So in the example that was shown for lambda, or for, was it for reduce? Where was the example for reduce? Here, right? Okay, so here we used a plus, but we put hash, and then apostrophe, and then plus, and then apostrophe 3. So hash apostrophe plus. Is that how it's got to be? Actually, yeah. I mean, maybe. Let's just see what happens if we put hash apostrophe. Is that better? It is. Okay, so what is hash apostrophe in common Lisp? Okay, hash apostrophe. The form, a faster way to type the special form quote foo. But what about with the hash in front of it? Func name? Oh, I'm gonna star this. This seems useful. Okay, so to get the function value of a name, we need, oh my goodness. Oh, that's cool. It actually, when he explained it like that, I think it makes sense to me all of a sudden. That's pretty cool to me. So, good. Let's do the next one. All right, so we did choice. All right, which do I think is the next easiest? I would say I think Full House might be the trickiest overall. I think Yacht is probably the next easiest. All 5 showing the same face. So for Yacht, we just do 50. But we have to, we do 50 if it is a yacht, else 0, right? So here we're going to say if and here it's going to be is yacht scores. All right, and so then if so, oh, actually, these are not parenthesized. If so, it'll be 50, and if not, it'll be 0. Okay, so there we go. So then we have to define the is yacht. Oops. Defun is yacht. Okay, which will take scores. All right, so do I want to try doing this maybe just with car and cutter and recursing? Maybe so. Maybe so. No, I just want to reduce, actually. So we are going to reduce the func will be number equals, and we'll just put the scores in. And What should the initial value be? We don't want an initial value. We just want to do that. No, that won't work. That won't work at all. We can't do that. Let's try and do it using a recursion. Okay, so common list is empty. Nil. Okay, so we're gonna say if EQ scores nothing, all right? So then in this case, what do we give back if we're recursing? Recursing? Goodness. So then the Boolean, let's see, common Lisp Boolean true. The symbols T and nil. Okay, cool. So in that case, we just say T, okay. And then if it's not, so this is really the helper, I guess. I'm just gonna say helper. Okay, so if it's the last, then true. Then if not, we are gonna say and is yacht helper and then this first one will be cutter scores and then this one will be car scores. And then this one will just be equals last car scores. Okay, that one got long. Yeah, that one got quite long. So let's at least have the if statement moved a little bit. So there's that, and then there's if it is, and then here's if it's not. I guess. So yeah, we have a base case and everything. I guess it could be okay. So then if I say defun is yacht, and we put scores in, scores, there we go, then we're gonna say is yacht helper, and we're going to put in header scores, and we're going to put in car scores. So that's like a recursive idea, but is it going to work? It might. Let's see what it says when we RAWs. Wow, I've already been at this for a while, huh? Okay, so... Okay, did we pass the yacht? Were 10 and 11 the yacht? Okay, that's actually cool if that passed. 10 and 11. Oh no, 1 and 2 were the yacht. What are 10 and 11? Oh, that's 5s and 6s. Okay, so 1 and 2 passed? Did they? They did. Amazing. I'm delighted. I'm starting to understand something. A little bit of Lisp. Actually, yes, I think I am. I'm going to give myself a pat on the back for starting to understand a little bit of Lisp, even if this is taking me forever to do right now. But hey, I'm starting to understand a little bit of Lisp. Okay, so let's do the next one. So we've got yacht. Okay, so then big straight and little straight are going to be quite similar, I would say. So I'm going to say... Now, do these have to be passed in ascending? I would think that it could be either way, right? Or actually, hold on. No, I don't think they have to be passed in order at all, do they? They could be passed in, I believe, in any order. So I think what that means to me is that, like, we take a bag or a set of the numbers that we're looking for, and then we see if they're all in there, I think. Common Lisp set or bag. Let's see. CL containers. More fun than kissing bunnies. Okay. Whoops. So this seems a little different. Let's not go there, I don't think. At least not just yet. Just use hash tables, as has been mentioned before. Yep, sounds like a winner. But, well, I guess I gotta look it up. Okay. Common Lisp hash tables. Okay, so this is a built-in. That sounds loverly to me, baby. Oh, yes. All right, all right. So they did a set F. Hold on. Okay, so you can use get hash in conjunction with set F. Okay, so we did set F, and then we did get hash. This is a little different. I don't, okay. Get hash. A key and a hash table. Huh. So this was defined like this, my hash. This is a good jam. What's the name of this one? Oh yeah, that's right. Okay. Wow, yeah, I'm not moving very quickly. There are various ways, right? There are various ways. So one thing we could consider, instead of trying a hash, one thing that would probably be a little bit quicker for me to implement, not having a ton of Common Lisp knowledge, maybe we could just do a sort first and then be sure that they're sorted in ascending order first and then look for the numbers that we require, right? So let's see. Common Lisp sort. Let's take a look. Okay, so we do have this. It looks like a built-in, right? So we did a sort, and then let's see. A sequence should be passed in, and then a predicate. Let's see. Interesting, interesting. Okay, so we did sort. Then we did greater. And the key was car. So we sorted by the first, right? So 7 is greater, then 4, then 1, right? Okay, let's try that. So I'm going to say dfun is little straight, I guess, right? Can we do list indexing? Common Lisp list indexing. Nth. Okay, I think we're good. Okay, so dfun is little straight. The scores will be passed in. Okay, so then first of all, we're going to sort these scores. And then when we sorted them in the example, let's look at this example again. There's still a lot that I don't understand. So I think we used this set q, right? So what is set q in Lisp? Set q. Set the value of the symbol. Okay, works for me, baby, works for me. Okay, so I'm gonna go set q, sorted scores, and then I'm gonna put sort, and I'm gonna put the scores in. That was the sequence, right? And then we're just gonna put in the function hash, yeah, there it is, less, so that they go up. All right. Okay, so then once that's done, let me put this on a new line here. So once that's done, we're going to go and, all right, and this first part is going to be nth, and when we use nth, it says we put in the, wait a minute, we put in the number n, and then we put in the list. Okay, cool. And it's 0 indexed. Okay. So we're going to put 0 sorted scores, but now we have to put equals, all right? And then the number that we want is 1, okay? And nth 1 sorted scores 2, all right? 3, 4, 5, yeah. Okay, so this will be 2, 3, and 4. And this will be 3, 4, and 5. Okay, and that's it. So we'll close the close. And yeah. So then here we say if is little straight scores, right? And then it's 30, but if not, it's 0. Okay, fair enough. Okay, so then here's similar. If is big straight scores, and we're going to say 30 and 0. Okay? All right, so then I'm just going to copy this. I was pretty happy about this. I think this is nice. For this one, I think I'm just going to copy it. And maybe consider refactoring, but for now, I'm not too sure about refactoring. Okay, so now these become 2, 3, 4, 5, and 6. All right, cool. Okay, let's clear and run raws again. Yeah, looks like that part was fine, so we're just missing 4 of a kind and full house. Cool. Cool, cool, cool. All right, so let's do 4 of a kind, and I'm saving full house for last. Okay. Okay, we did these two. All right, so 4 of a kind. All right, I'm gonna try it recursively, similar to what happened with this is yacht helper. All right. So I'm gonna first defun is 4 of a kind. Scores goes in. All right, so now what needs to go into the helper? So is 4 of a kind helper. We'll put in the cutter scores again, I believe. And the car scores. But now I need to put a forgiveness, which is 1. I think when I try doing things this way, it usually doesn't work well. Okay, so we're going to defun is 4 of a kind helper. And what gets passed into here? It's going to be the scores, it's going to be the last, and it's going to be the forgiveness. Forgiveness. All right. Okay, so then the first thing is our base case. If EQ scores, all right, then 0 is coming out. Okay, and then in this last one, this should really be, it's not is, it's score 4 of a kind. Because we're going to try to pass back the score, I think. I hope I don't mess it up too badly. So then here, we are going to say what? If less than forgiveness 0, then 0. And then here, we actually add it. And that's going to be, so we're going to make our recursive call here. So it's going to be score 4-of-a-kind helper. And what gets passed in there is going to be the cutter scores first, then the car scores. And I think we're plussing, right? We're adding whatever comes out of here. This doesn't make sense. I need to subtract one from the forgiveness if the car scores is not equal to the cutter, or to the last, excuse me. Okay. So this is going to be if equal last car scores. All right. So if they are equal, then we do this. Okay. So that gets passed in. And then here, we need to do last. I guess so. I don't think it's going to come out right. Do I need to think it through on paper? So if it's 4-of-a-kind, and let's say that they're all ones, so it's 1, 1, 1, 1, and then the last thing passed in, it could be whatever, it's a 5. So the 1 is going to be passed in, let's point at it. The 1 is going to be passed in here and become last here, right? And then we're going to see if it's equal to the next thing. And if so, we will add last to all these. I hate it. I hate it, actually. There's another thing we could do. You remember that weird thing, finding the odd one out? So if I have a list of numbers, and then there's one odd one out, and I reduce, and I go ACK bitwise XOR E, then if they're all the same but only one is different, does the odd one out always come out? No. It's if there's an even number, and there is an even number in the case of the 4s, right? So if this could be like a 5, and this is 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 a 5. So however many there are, right? But we're only dealing with 5s, right? So, you know what? I actually don't know how I want to approach this one. What are the other languages for this one? I made kind of good progress, I think. but I still find Lisps tricky, right? Because I haven't practiced them much. I haven't practiced them at all outside of this 48 and 24. I think that both Rust, I think Rust should be easier. I think I'm actually not sure about F#. Let me jump into it in Rust now. So I'm gonna put a pin in this. I'm gonna try and finish it tonight, but I'm gonna put a pin in it for now. And close out all of these. And I believe this is gonna be easier for me to approach in Rust. I'm not sure, but we'll see. We'll see. Oh, it's listed as a medium. Okay, so let's go to Rust. Okay, so I am going to copy the work that I was just doing into here. Oh no. Okay, so I copied all that into here. Oh no, I messed that up. Okay, there we go. All right. How late is it getting? 8:30? I don't know. I'm still supposed to go to Advent of Code and Advent of Cyber today. Ooh, man. Okay. Okay, so we'll first do we match Rust match statement? And we can do this on an enum, presumably. Okay, well, whatever. So we'll say match category. And then do we use, like, arrows? Fat arrows. Ooh, lovely. Okay, so ones. Okay. So now let's say function n score. So this one takes in dice. No, it takes in n. And that is a what? I guess it's a dice. So then this returns a function which takes a oh no, this is not dice. This is U8. Okay, so n is U8. So then this function takes in dice, and gives back a U8 score. Okay, so now let's see, what was that Wikipedia page? It probably has Rust on there too, right? It had tons of things. Rust. Okay, so here it is. So they did iterator And so it looks like it's a fold method, right? Okay. So then we're going to return function dice dot, and then we'll put fold. Okay, init value will be 0. And then this other function will be function ac u8 die u8 returns u8, and we just add them together, it looks like, right? Oh, no. You say if Rust if statement. Okay, so if die equals n, return ac plus die, else return ac. So this should give back a u8, and then this should return I'm nervous. Do I not have a helper? I guess I don't have a helper. Okay, so now let's try a test. Okay, so we're looking at 20 expected 1 of colon. Okay, so let's see. Rust lambda function. Closures? Oh, okay. Yeah, we want that. Cool. Yeah, that would make more sense. So what did I have? So I did it like this. So we don't need that. This becomes a pipe, right? And this one becomes a pipe. Okay. And then this one similarly. Okay, now what does it say? Expected function pointer found closure. Oh, okay. Closures can only be coerced to function. Okay. So if we return a closure, interesting. So now it's not this, it is now this. No, it is this. Oh. That's pretty cool. Okay, so now what does it say? Oh, no. Expected type found pipe. So let 1 equal... Once a closure's type has been inferred, it cannot be inferred again with another type. Okay. So, is there more about it? Capturing. Do we have a return in here somewhere? Oh, shoot. Return. Oh, maybe not. Okay. So this is expected type. Okay, let's see if it's on the next. As input. Okay, so this is all about closures. Impl? What is impl? Okay, okay. What is move, though? The move keyword must be used? Oh, okay. Impl function. Okay. This is, yeah, it's pretty, Rust has a pretty intricate syntax and like type system, I think, right? Okay, so this is a function which takes this and returns this. Okay, now what does it say? Expected one of, found colon. Here? Oh, interesting. So now it says, expected expression found closing. Okay, cool. So we got down to here. All right, so then ones, we are going, sorry, we are going to like return and it's gonna be n score 1 dice. Oh, is it comma? Okay. Twos. Okay, so let's do twos, threes, fours, fives, sixes. Okay, so then we'll put those numbers. So this one will become 2, 3, 4, 5, 6. Okay, so now what does it say if we do this? Oh, okay, it turned into a lot of output, which is probably a good sign. So first things first, not an iterator, so we can't fold this. So can we get an iterator from an array? Rust array iterator. I'll bet we can, right? I'll bet this answer has a quick answer. Oh. Wait a minute. So they use into iter here? Okay. Let's try into iter. Was that any better? I think it might have been. Okay, let me clear. Rust is a very interesting one. I think it would be very rewarding to get good at Rust, right? A lot of people are very good at Rust now, of course. Okay, so interesting. So expected a function U85 closure found this. Huh. Help. Remove this semicolon. Okay, so let's remove that semicolon first of all. And then here, we should qualify the path using double colon. Okay, let's do those couple of things. So here, was it this one they said to remove? Wait, which one was it? Was it the one after the if? It was the one after the move. Oh, okay. Do they have it after the move here, wherever I was looking? Let's find it again. It was it this? Oh, no semicolon here. I actually don't know why. Okay, so rust semicolon. What does it mean? Generally not optional. Okay, so why semicolon? Wait a minute. Chapter 5 of Rust book? Okay, where's the Rust book? They said it's in chapter 5, right? Okay, so here's the book. Let's find chapter 5. No, hold on. Data types, guessing. Okay, so where do we search the book? Semicolon. Okay, so oh, here's what we just saw, right? It's an expression whose value we want to return. Oh, okay. Okay, that's neat. All right, so let's try and fix this. So we want to remove this one after the move, and then here we want to say that it is going to be category, right? And then here as well, right? Okay, let's see what it says now. All right. Oh, it's much shorter. I don't know if that's good. Non-exhaustive patterns. Okay, let's add the rest of the patterns in there. So it's going to be, let me just get them from up here, I guess. Okay, so it's going to be these ones. Whoops. Okay, and then we're going to put equals return, and then I'm just going to put 0 as a placeholder, I guess, for now. Sure. All right. So it said, okay, but it said running 0. Okay, running 29. Okay, so almost all ignored, but we did not ignore one of them. Test yacht. Okay, so let me go into the tests. And yacht rust file. Okay, check it out. So I have ignore. So for now, I do want to ignore this one and this one, because I'm not doing those ones yet. But this one, let's not ignore. Yachts counted as 3s? Oh, interesting. So turn these ones on. No, not that one. Let's just do those ones. So, okay, I got some okays. Did I? Oh, 9 passed. Cool. And we didn't get any failed yet. Okay, let's move on. Next. Oh, right. Let's do source. So, in my Lisp code, I guess I've got, so this is the N score, and I think that part is fine. I must admit, I think this looked nicer in the Lisp, but that's okay. Okay, so we got that. Let's see, we don't need this boilerplate at all. Okay, let's look at is yacht. Okay, so this time, let's not try and do it recursively or anything like that. Let's just loop through like normal human beings. So I'm going to say function is yacht. All right, so now what does this one take? It takes dice, and that's pretty much it. It gives back a bool, right? Okay, cool. And then, so what we did here is we sort of went recursively and we looked at whether the last was equal. So yeah, that's funny. That one looked way worse in Lisp. Okay. So we're gonna say for. Now, do we have Rust 3 clause for loop, I'm hoping? I actually don't know. I've hardly done any Rust ever. Loop expressions, let's take a look. Let's just do a while. A while is easy enough. So we'll say U8, I guess, oh, it should infer it, right? Do we just say I equals 0, like this, and then say while, and then say I is less than 5, because there's 5 dice, I guess, and then say, well, actually, let's say 4, because we're comparing it to the one after. So then we'll say if dice sub I not equal dice sub I plus 1, return false. All right, and then we increment, so we'll say I plus equals 1, and then we'll return true. Okay, let's see what it says. Okay, so I think we have to say, what do we say? Do we say var? I think we say var. No, I think we say mute. Is that it? Let's see. Mute I. Invalid. Oh, we have to say let mute. Okay, fair enough. All right, so now we have to go back and turn on the yacht tests. Oh, is there any other warning though? Hold on. It says, warning, is yacht is never used. Okay, so we have to add that in. Nice reminder, nice catch. Okay, so if it's a yacht, then we return is yacht. If I could spell, I guess not. Dice. So if so, we will say 50, and if not, we will say 0. Is that allowed? I don't know. It's a, okay, so we cannot do. Wait a minute. Rust ternary. Okay, so we'll do that. Okay, so we will say return if. So if it is, then we will say 50. And if it is not, then we will say else 0. Yeah? All right, so now what's it say? Okay, cool. So no warnings, it looks like. Okay, so let's turn on those yacht tests. Okay, so I want to unignore this one and this one. Yeah, let's just do those two. All right, so 11 passed. Okay, progress. Okay. So let's delete this part of the Lisp. And did the 4 of a kind work? No, I don't think it did. I think it was messed up. But the straights worked. Do I want to do the straights the same way? Actually, no. I don't think I want to do the straights the same way this time. I think I would rather try to use a set. Okay, so rust, set, or bag. Hibernate? This is Java. Collections. A hash set. Yeah, that sounds like a winner. So in the example, they did new. Do we have some kind of like a hash set literal? Oh, we can do this. Yeah, that's a winner. Let's just do that. I'm going to copy it. Copy. Okay, so let mute set. Yeah. And we'll say hash set from. And I'll just add a couple more. Cool. That's almost perfect. So now, so this time let's do a different loop, like for each. Rust for each. Okay, cool. So we're gonna say dice 2iter for each. Okay. So then they put a closure in there. That's cool. So let's do that. I like this one though. Item in iter with the for each bang. For each trait and for each macro. I think I actually just want the for in loop, actually. Rust for in loop. Let's take a look. Okay, so yeah, let's do that. For, and then we'll say die in dice 2iter. Oh, into iter. Oops. Set dot remove. So we have insert, okay. And then is it remove? Okay, remove, excellent. So now we will say return, then we'll say is empty. Yeah? I think so. All right, so now I would say, so I just copy pasted this in the Lisp one, but that shouldn't be necessary this time, right? So really, function is little straight should take dice, return bool, but then it should just return as all, and then put in the dice, and then put in 1, 2, 3, 4, 5, right? And then has all will be pretty much the same as this, but then here we'll say wanted, which is, I guess, dice again. And that will be wanted. Okay, and then so is big straight return has all dice 2, 3, 4, 5, 6. Okay. Use of undeclared type hash set. Okay, so we should use standard collections hash set. All right, let's do it. Use standard collections hash set. Looks like it's a double colon. That's cool. Use, wait a minute. Oh, not applicable here. Okay, that's an annotation or something on there, right? Something like that. Expected and U8, found U8. Okay, so we have to use the address of. Is that address of in Rust? Is and address of in Rust. Yeah, what's the and here? Represent references, refer to, okay. Refer to some value without taking ownership of it. I guess. All right. So now it says 11 passed. Okay, so warning, has all. Okay, so now we're going to go ahead and try to use that. Oh, wait, it should be, okay. So now, big straight, we are going to return if is big straight, dice, 30, else 0, right? Okay, so then this one will be his little strings. Okay, and then, okay, so no more warnings. Let's turn on the tests. So this one is for a straight. So let's turn that on. Turn that on. Turn that on. Quite a good amount of tests, it looks like. That's good. Okay, let's see. 19 passed. Okay, so there's just 10 left ignored. It's progress, baby. It is progress. Okay. So we did these, and I think, let's see, do I think this came out better than it did in Lisp? I would say yes. Using the hash set is kind of what I originally wanted in Lisp. Sorting is just not as good. It's okay, but the hash set is what I wanted. Okay, now we have just 4 of a kind and full house. I think that's all that's left, I believe. Oh no, I never did choice yet. Choice was an easy one. So in Lisp, for choice, I just actually reduced the scores with addition. So that was really nice. Okay, so let's do choice. So we know we used a fold, which was dice into iter, fold, and then we put a starting value and then a closure. So let's try it again. Okay, so we're going to put dice into iter, fold. We're going to put 0, and we are going to put... So this time, let's see. What if I just put ac Can the types be inferred? I guess we're about to find out. And then I'm just going to say ac plus e. It says closing delimiter. Okay, so I messed that up. I put that there. Oh, yep. Any warnings or anything? Okay, no warnings or anything. Cool. So let's turn those tests on. Okay, so those are the only ones for choice. And so those passed. Okay, so now we get to the good ones, the 4 of a kind and the full house, which I think are going to be much easier than what I was contemplating in Lisp. So let's see. All right, so I don't need any of this. And this was not working and is not at all the approach I'm going to attempt. But we do want 4 of a kind. All right. Wait, full house is total of the dice same as choice? So why don't... So full house isn't even good. Am I crazy? Wait. Huh. Oh, that's goofy. Interesting. So, like, choice is very often going to be the best option, isn't it? Choice should always be better than ones. Wait a minute. Huh. That's weird. Should I should I learn about this? It doesn't really make sense. Why is choice sum of all dice same as full house? So why would you do four of a kind? Do I not understand? Hold on. Once a category has been used in the game, it cannot be used again. The scoring categories, okay. Oh my goodness. So you can, okay, 12 rounds. So you can use choice once, but then it's gone. Okay, well, that is crazy. All right. I don't think I quite, okay, I guess I get it. So you can only use the choice once. Was that mentioned here? Chooses one of 12 categories. No, I don't, wait. Yeah, I don't think they mentioned it, but it's not really relevant to the actual program that they're asking us to kind of do. So let's do function score for of dice U8. So we'll return, so no, hold on. So we're gonna go, I guess we're gonna go through all of them. And are we gonna like count? Maybe we should just count. We could also use the set to see how many there are. I think we need to just count, actually. So we're going to say let mute count equal hash map. So do we want hash map? Okay, let's look. Rust hash map. In standard collections, and they just do new. Oh, double colon new. Is double colon for the static? Okay. So then we're gonna go 4 die in dice into iter, I guess. And then we're gonna say if, and then on a hash map, we're gonna say contains key. So we'll say if count contains key, and then I guess we have to put the and die, or it's not really address of, is it? Because what they were saying here is it's like refer to some value without taking ownership of it. So dereferencing is with star and referencing. So it's referencing, not address of. I like that. Okay, so we're going to pass reference to die. Cool. Great. Okay, so we'll say count. And then do we use like set? Okay. And then get. Oh, I missed something on the insert. We need to put the key in there. And that goes where? The key is first. Okay, so insert. Okay, so then into values. The map cannot be used after calling this. If count values, and then do we have like sum? We had reduce, right? Actually, it was fold. Excuse me. It's gonna get really late. Oh man. All right, so fold is here, and we want sum or any or something like that. Any, yeah. So here I didn't put a reference operator on these things. Okay, so I'm going to say not. then on the hash map, so if not, okay, so then we'll say else return count values, and then is it like find maybe? All key value pairs. Yeah, let's do that. Iter find okay, seems crazy. Let's see what the message says. Okay, so cannot add integer to option. Oh, okay. So in this case, we just checked that it's in there, right? So we said if it contains the key, then we're going to get it, right? But it's an optional, right? I think we want expect because, let's see. Just checked for key. Expected closure that takes one argument. So is it was it a tuple here? What was it? It was the hash map iter. So I guess it is a tuple. Okay, so there did we also just check? So yeah, if we couldn't find any, then we returned 0. So here we should assert that we actually found some. Expect checked for value 4 in the end. I put that in the wrong place, right? when it was supposed to go at the end there, right? Okay. So rust tuple. So if we have a tuple, can we just use like square brackets to get something out of it? Let's see. Rust tuple indexing. Let's see. They put a dot. Oh. And then, so this is going to be, let match equal. Return so not match. It's borrowed value does not live long enough. Oh, well then. So not that. I think we have to actually pass it. Is that more like what it is? Now it's getting now it's exposing me. Okay, so now there's a lot. Okay, so expected and something found U8. So we can't do that on contains key, I guess. Expected reference. Consider borrowing here. But we can't really borrow because we're in this loop, right? Interesting. That does seem interesting. So we had a reference, but then it was like, oh, hey, it's going to go out of scope, and so you can't borrow it from here, right? Interesting. Hmm. Okay, so Rust borrow in loop. I'm gonna have to take a break. I'm making like no progress. I haven't even finished one yet, and it's been 2 hours. I told myself that I should finish everything for tonight in 3 hours, and I'm obviously not gonna hit that. Um, and then like advent of code ticks over, right? In 30 minutes. Okay. I think I'm gonna move from exer. Oh man. Oh man. All right. I need to take 5. I'll be right back. Cloudsmith? Okay, so one other thing. Let me close these. The other yacht was in F sharp. Okay, so that's probably not going to be any better for me. Actually, it might be. Let's jump in here. You all arrive at a lava production facility on a floating island in the sky. So it says a good hiking trail is as long as possible and has an even gradual uphill slope. So if we start at 0, and then go to 1, and then go to 2, and then go to 3, and then go to 4, and then go to 5, and then go to 6, and then go to 7, and then go to 8, and then go to 9, then that's cool, right? Fill in the missing hiking trails. Okay. Always increases by a height of exactly 1 at each step. So we can see that there were more than one trail, right? I think we're going to return the number of trails. Okay, so 1, 2, 3, 4. So 9 trailheads. All right. We're going to try it. So I want to say this part of it seems like it's probably kind of straightforward. The trouble is we are going to have to do backtracking, right, to be able to discover, like, if there is a path, right? It's pathfinding. So, I mean, I guess that's fine. In fact, yeah, that's more than fine. It should be pretty simple. So let's look at the small example first, I guess. Okay, so here's a tiny example. All right, so we want to find a 0 and then from a 0 we want to find just a 1, right? So like kind of straightforward, I guess. Okay, so let's do a find branches and we'll put in x and y coordinates. And I guess we'll put the map in as well. Let's make the map first. So make map takes in a puzzle input, right? And we'll just split it. I'm a mess right now. I should stop, but like I haven't finished anything. So, I mean, it's getting close to 10. Okay. Okay. Puzzle input split. Map. So make map I. So does this look like a map for us? Okay, cool. All right, so then find branches. We'll take a map, an X, and a Y. I honestly feel a bit defeated today. That darn, I spent so long on that Common Lisp and on that Rust, and I don't have answers. On something relatively simple, you know? All right, so branches equals this. If x greater than 0, and map sub x sub y sub x minus 1 . Oh, wait a minute. You know what? These should be numbers. That'll be easier, right? So let's revisit the make map real quick. Okay, does this look better? Yeah, that'll be better to work with, I guess. Okay, so back to the find branches. Right? Do that. Okay, makes sense. Okay, so now if y sure. Okay, next. If x less than okay, so now we plus and plus. Okay, so now, oh, wait a minute, wait a minute. Okay, so then this one will be y. Then we plus 1 here and not here. That's fine. And then we plus 1 over here instead. All right. So there you have it, I guess. So let's find branches. So let's say my map equals make maps I. All right. So now find branches my map 0, 0. All right. So we got 1, 0, and 0, 1. So those, of course, are correct. Those are where we can go. All right, so now follow path is going to follow until we find a 9, right? So we're going to go follow path equals, and we'll take a my map, and we'll take a 0, and we'll take a 0. All right. So we think that a 9 is the highest number that we're going to get, right? So let's use that as our base, as one of our base cases. I think we need more than one here. So if, oh, why did I do that? X, there we go. So if my map y x equals 9, so then reached the end of the trail. So I guess if we've reached the end of the trail, we want to return true, probably. So that means it's, if it's a Boolean, I guess then it's going to be, should we say path exists? Okay. Let's say something like that. Okay, so what's next? Yeah, so we need that base case, but other than that, I think we're good. So we're going to say branches equals find branches my map xy. Okay. And then we're going to say return branches any, right? And so we know we get an x and a y out of there. So let's call it branch x and branch y, I guess. In JavaScript, it's sum, right? Okay, so then path exists, my map. I think I'm just going to say it like that. So that's actually pretty simple, right? So now path exists, make map I 0, 0, and it comes back true. All right, so in that small map, was there any place where no path existed? Here you could go to, I think a path exists everywhere here, right? So now let's look at this larger one. And then I actually kind of I got excited and kind of forgot that we were supposed to count numbers of paths, but all right, we'll get there, we'll get there. Okay, so let's do this. And we'll put in this input instead. It's a little bit larger. And so there is a path from, so it said, according to this, they all have paths. So whether the path exists is not really the point. So we want to say, let's redo path exists, and we will say number of paths, right? Okay, so it's going to be quite similar. So we'll start from here. So we'll say number of paths. All right. And so here we'll return 1 instead of true. And then here we will return reduce. And we'll put the ACK in here, I guess. And then we'll say number of paths here. And then we'll add the ACK to it. And then we'll start with 0 so that we can get a sum. Right? So, I mean, it's not a lot to code. It's pretty basic. So now let's do number of paths. And then we'll say make map. We'll put something in here. And let's start, so on this one, let's start with 2, 0, because there's a 0 there, right? Okay, and then let's paste this smallish map here. Okay, so I've got 20. That's far too many. So that's the number of, that's probably the that may actually be the number of paths, but we weren't supposed to return the total number of paths. We were supposed to return the number of summits that we can reach, right? So it's again going to be similar, and number of paths is not bad, but it's not what's asked for. And I think I kind of, I did. I thought it was what was asked for, I think. So let's say reachable, and what do they call it? Endings? For every 9 reachable. So they do say reachable. So I'm just going to say reachable. All right, so then here, I'm going to use a closure. So I'm going to say I'm going to call them summits. That's kind of what, I feel like that's what they kind of represent. Not exactly, but I'll just call them summits. And I'm going to say new set. All right. So then I'm going to say find reachable equals my map, or let's call it, I'm just going to call it M, and then, I don't know, XR, YR, I don't know, I kind of hate it, but sure. Okay, so I'm going to say find reachable, and that's going to be this part. And so then we'll return find reachable my map. Actually, this doesn't need to be passed in again. We just need the recursive X and the recursive Y. Okay, so then we'll use YR, XR here. And now we are gonna say so we're gonna find reachable, and we're gonna return summits. What is it? Is it the size? One sec. Okay, I'll just say that. Okay, so new set 1, 2, 3 size. Okay, so it's size. Yeah. Size. So size gets returned. So reach the end of the trail here. So we're going to say summits add. All right, and we'll just add an ID. So we'll say X, Y. So we'll just add a string like this, and this will be XR, and this will be Y. Okay, cool. So then we'll do this this is find branches, and then the recursion is we actually just kind of have to search everywhere. And we don't have to reduce or anything, we just kind of have to go for each. So we'll go for each. We won't have this. We won't have this. This will be find reachable. We decided not to worry about passing that in. There's nothing like that. And, oh. Let's say it takes them in this form so that we can just say find reachable. There, that's nice. And then we have to put them like this here. Okay, cool. Yes, 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 yes. Well, let's see what we get. Whoops. Missing. And where's that? Oh, right here. Oh. Is that better? I think so. Okay, so we're going to say reachable. And we'll say 20 again. Oh, that's not good. That's not good. Okay, so I forgot to add return in here. I had it in my mind for like a very short second. Okay, let's go again. Oh no, it's still no good. Yikes. Okay. If my map reached the end of the trail, we'll add the summit and return. Okay, so far so good. Find branches here, and then branches for each. Find reachable. Oh. So if there were no branches, we shouldn't... Oh no. So find reachable is this. We call it here. Darn, I've messed this up in a weird way that I didn't understand. Okay, so summits add. And then we go branches for each, find reachable. Man, it should be simple enough. At this point, I think part 2 is going to be a lot trickier, but I totally messed it up. Huh. Okay, return branches. Yep, I see it, I see it. My bad, my bad. It was right here. Okay, so it says 5. Is 5 what it's supposed to be? Okay, in reading order, it's 5. Okay, let's see if we get 6 for the next one. So this next one is still at... No, this next one is now at 4. So I got a 6. Okay, so the next one is still at 4, but now the Y is at 2. I got a 5, sure. All right, where's the next one? Looks like we're over to 6 and 4, is that right? I got a 3, that's what we got here. Okay, So now there's another one at 2, and what was it? 5? I got a 1, sure. Alright, so now 2, 3, 4, 5. So this one's at 5, 5, it looks like. And it says 3. Wait a minute, wait a minute. So I got the 1, the 3. So now it should be 5, 3, 5. Okay, so then this one's at 0, 6. And I got 5. And this one's over here at 6, it looks like. And got 3. And then at 1, 7. Okay, so sure, there we go. So now when we want to add them all together, so let's say solve equals puzzle input. All right, so let's go back to, can we go back all the way to the top? Yes, amazing. So make map is this one, right? Okay. So I'm going to say const. All right, I think that's okay. Then what's the next one we want? Reachable. So what we finally decided for reachable was this. So let's put that in there. It ended up looking more complicated than I thought it should have. Should I try for a refactor here real quick? Okay, so new set, find, reach the end of the trail, add the summit, add the summit to our set, find the branches. Yeah, I mean, it's still pretty straightforward. So we need to add the find branches. Okay, so let's make this one, let's tab these over, I guess. I'm going to put them into prettier here real quick. We also need the find branches, which worked just fine. That was this one. Oh, this is going to look kind of big. All right, so I'll call that const as well. This one will also be const. Yep. So for this, we just need to do this once. So I'm just going to say my map equals, and we'll just split it like that. That doesn't need to be a function. Okay, so then this will be the end. All right, so now we just have to find all of the 0 locations, right? So let's just say for let I equal 0, I less than, actually, should we just call it y? Y equals 0, y less than my map length, y plus plus. For let x equal 0, x less than my map 0, my map, so y, I guess, length, x plus plus. Okay. And then let's say let sum equal 0. So now here we say if my map sub y sub x is 0, sum plus equals reachable my map xy, and that's it. Okay, so let's solve. So this one, this tiny one should just give us a 1, right? So then here is one that we think should give us a 2, but the problem is it's not gonna give us a number, right? It's gonna say, oh hey, you put in something that's not a number. Oh, actually it says it's okay. Oh, it just goes NaN, right? And in this case, that's actually fine. That's actually fine. Okay. Let's do this one. Or let's do this one. Three. Okay, so we added up the two different scores. And so then this one should come to 36. Okay, looks good so far. Let me put this into prettier. Okay, so I'm just going to call this one AOC005, even though that's not the real number. Okay, so we're going to grab this solve, copy, paste, prettier, 5. I like this one a lot. Let me see the song. I think last time it came on, I was like, I really like this a lot. I like this one. So anyway, so now we cat. All right, so here's how it looks now after being prettiered. Okay, so I'm going to come in here and paste it. Okay, so here's how it looks. Solve, puzzle input, my map. I really would like to use ESLint on some of these as well, because ESLint would definitely find some things. All right, so this is fine. And then reachable, reached the end of the trail and found a summit. Oh, that should be, let's make this const. And this one const. And then so we don't need to actually pass the map in there. We just have X. It's in scope. So let's just not even. Yeah, I think that's fine. And then even find branches, like, honestly, we still have it in scope, so let's just, man, I have a ton of places in here. Okay, I feel dumb about that change. Okay, so find branches. So find reachable here. Okay, so here I'm gonna say like this. I'm gonna put it in parens. And then just do this. Okay. Undefined is not iterable. Darn, I messed it up. At find reachable. So did I need to pass my map into there? Find branches. This should be const as well. I shouldn't have messed that up. Find reachable. Symbol iterator. I don't think that should be a thing. Should it? Is it because of what I did with this function? Oh, I didn't pass anything in here. There's my problem. Okay, now I got 0. Alright, where's my console log? Darn it, why did I mess the whole thing up trying to refactor? That's very terrible. So yeah, nothing came out each time. Okay, the map looks okay. At least I think so. I wish I never had to sleep or, like, eat or anything. Alright. I passed something wrong in here. So, XR, YR. Yeah, that's not supposed to go in there. There! I think that should fix it. Oh my gosh. Okay, so I got the 36. Let's get rid of the consoles. I don't know if I'm happier with it this way. Okay. But let me prettier it again, and then let's throw in the actual puzzle input. Alright, let's give it a shot. I got 822. Okay. Now part 2, I think they're going to make it much trickier. Let's see. Because, I mean, they made the pathfinding really easy, right? Like, just look for the one that's +1. So, a second way to measure a trailhead called its rating. A trailhead's rating is the number of distinct... Oh. Well, that's what I solved first. Okay. That one is actually easier. Okay, it's a reprieve. I call this a reprieve. However, I kind of want to go all the way back. So it was called number of paths, right? Okay, so this was my final number of paths, right? And then I was like, oh wait, that's not what they want. That's kind of funny. The number of paths is actually quite a bit easier, in my opinion. I mean, it's not a big difference. They're very similar. But anyway, so yeah, let's go look at our solve. Copy this again and paste. And then let's put number of paths in here. Okay, so reachable. And then let's put number of paths. So this is going to be const. I'm not going to pass this in. This is going to be const. We won't pass this in either. And yeah, I think that's it. So then, so we're going to sum it for all the trailheads. Okay, let's see if we get the same answers. So now I'm going to change this. So this will be number of reachable summits. And we'll say let number of trailhead paths also equals 0. And then here, we'll do this will be reachable summits. Okay. And then we'll say number of trailhead paths plus equals number of paths. And we'll say xy here as well. And then we'll return number of reachable summits, number of trailhead paths. Okay. Okay, so now let's solve this one. So it says 81 should come out. Uh-oh, it came out 0. Let this, okay, so number of paths. So reach the end of the trail, return 1. Branches, and then we reduce. And where did I mess it up? So we should still have my map equals 9, return 1. Find branches should work the same. Let's see. We came out with, what did we come out with? 36. Number of trailhead paths. Number of trailhead paths plus equals number of paths x1. I passed something that didn't belong right there. Okay, let's do it again. That's what I get for changing function signatures. That's crazy. Okay, so now I have an 81. And, I mean, yeah, honestly, I think that's the answer. So let's look at this again. Okay, I've got 1801. Copy. Nice. So now, if we look at the calendar, this one has dropped now. I'm not going to do it right now. What I'm going to do now is I'm going to take that solve and put it in my prettier one more time. That was quite an easy one, really. It sure didn't take me as long as messing with that Common Lisp and Rust. Okay, so sure. All right, so that's what I've got. Okay, so that seems fine. Yeah, reached the end of the trail. Okay, let's go to Advent of Cyber, and as soon as I finish it, I'm going to call it a night. And hopefully it won't be too long, but Exorcism really kicked my butt today. Holy crap. I don't know. I didn't allow myself really much time, honestly. I mean, I should have already been done with everything by now. I don't know. I don't have any excuse. I think really what it was is just skill issues with Common Lisp and with Rust. I think that's all it was, pure and simple. Okay, so this one, oh, so 15 and 16 are unlocked on this one. I'm not going to do more than one. I'm going to do one of these. I'll do 2 tomorrow. It's fine. So this one is GRC, Governance Risk Compliance. Didn't we see this before? You know what? I think I saw it on my Mac when I sort of just accessed and poked around the site. All right, so let me just go to the bottom and see what it is. So we're going to get a flag. We're going to get a GRC. Wait a minute. This isn't what I did already, is it? I did this one already. It's not marked complete. Okay. Oh, I never marked this. Oh my gosh. Huh. Okay. All right. I guess I'm not behind after all. I was very confused. Okay, so we're on fishing. Okay, so let's take a look. So in the end, we are supposed to find a flag text file on the administrator's desktop. So I don't know, I kind of just want to just go ahead and do it. Phishing module, is it premium? Oh, interesting. Well, I'll star that. This one is actually free, apparently. Is that what this means? Oh, it's not a room, it's a whole module. What are modules? A learning pathway is made up of modules, and a module is made of bite-sized rooms. Think of a room like a mini security lab. Okay. Well, interesting. And so is this a room? And it's a free room. Okay, I'll star that one as well. Okay. But here's the deal. Let's just try and... oh gosh, I don't know how much I'm going to have to do. So we need the VM and the attack box. What are we going to do? Create a document with an embedded malicious macro. Listen for incoming connections. I'm going to stop now. I'm going to do this tomorrow after work. Because I get off work much earlier in the afternoon tomorrow. Right? So on Tuesdays, I always get off work at 7. And Wednesday through Saturday, I always get off work at 4. Yeah, alright. So, one thing I did notice, I think that I have finished over 100 of these now. Oh, actually, 100 exactly? Okay. Well, I'll take it. Finishing 100 is pretty good, but apparently that means that there are still 4, let's see. Still how many? 44? There should be 44 left uncompleted then, which is still so many, honestly. Yeah, if I'm being very honest, I don't think I'm going to finish this. Like, as of right now, it doesn't look like I'm going to finish. So yeah, that's crazy. We did Minesweeper and Crystal. How simple was this Minesweeper? It was pretty simple, right? Oh man. There are still so many more, and a lot of the ones that are left are hard. I wonder if this last one that they dropped is hard. Largest series product? That doesn't sound too hard. Let's give it a shot in Lua. It'd be nice to at least finish one today, right? Largest series product? I don't know, it doesn't necessarily sound hard. Let's see what it is. So according to this, we are going to take an input as a sequence of digits. So a series is oh, interesting. So this is almost a more algorithmy one. So that's cool. That's interesting. So oh no, I know this one. Let's take a quick look at these tests. This is one that they gave us the first day in my discrete math class at the university in 2018. I remember this one. It made it like, I don't know, it made a big impression on me. I was like, whoa, that's cool. I don't know if it's the same one, but let's look at the tests. Okay, check it out. Largest product of 2 with ordered digits. Oh, interesting. So the span has to be 2, so we have to take the 2 largest, right? Largest product with a large span. Okay, so 6 is a large span. Oh, okay, and this one's a really large span, I guess. Okay, so interesting. So no, this is not the problem I was thinking of that they introduced in that one class. Okay, so here's what I believe we are going to do then. We are going to start, let's look at a smaller one. So we're going to start by taking 0 times 1, all right? But we're going to treat 0 as a special case. So this is going to be 0, and we'll set that as our largest, and then we'll just move on. Okay, so then here we have 2, all right? So then when we increment again, we're going to multiply by 3 and divide by 1. This is why I say 0 should be regarded as a special case, because of course we're not going to divide by 0, right? Yeah, it is actually pretty simple. And so it's going to be Lua. Yeah, this should be finishable in Lua, I think. I'm definitely not good at Lua. I find Lua pretty confusing for the most part, but this is technically quite a simple problem, I believe. So the config is going to look like digits and span, right? Okay, so let's look at Lua loop. Okay, numeric 4. Let's look at Lua string length. Not that one, I don't think. Where's the actual Lua? Yeah, right here, string library. Okay. So we're going to go 4. We are going to go I equals, and then we're going to go 1 through string length, and then we're going to pass in the config, and what was it called again? The config digits, okay. And then Lua get from table. It was called a table, right? Okay. All right, so that's going to be config digits, right? But this one, so this should actually probably well, let's start it at no. Let's start this at config span. Lua string to int. Do we do toNumber? Somebody's saying toNumber. Coercion. Okay, cool, great. So now, so we're gonna start by saying product. Oh, and Lua declare. I've looked at all of these. I haven't looked at all of these. Okay, so just like this. One, and then I'm gonna go for I equals 1 through config span. Okay, and then what happens next in our for? Oh, so, okay, so we say end here, and we say end here, and then here we say product times equals product times config digits I. Seems right to me. And if one of those is 0, it just ends up as 0. Okay, so now I'm going to say first equals config digits sub 1, okay? And now here, we're actually going to start at the next one. And then here, we're going to say if first equals 0, all right? And then we're going to say product equals product times config digits sub I. Okay, so now we're going to say max equals product. Okay, so then we're going to say else I love blonde and yellow. Followed. Thanks for the follow. I love blonde and yellow. I appreciate you. Okay, so here we divide first. Okay. And so then if product greater than max, max equals product, and something else just slipped my mind. What was it? Oh, then we say first. First equals config digits, and then this is going to be I subtract config span. So let's see. So if the config span is 2 and I is 3, I think, okay, so we want to add 1 here so that it's the next first over. Okay, so then at the end we return this. Okay. Do expected near product. Okay. Oh yes, so the 4 has a do in it. I don't think I recognized that. Emmy Lua LS. Let's see what this does for me, if anything. I think I freed up some disk space deleting Steam games, but I don't know if I freed up enough. Okay, that one's installed though, so that's good. Is it gonna give me... Oh, interesting. Okay. Love it. Yep, I did miss this. No attention to detail, baby. So does then go here. Ah, yep. I need help like that. That's the kind of help that I crave. Love you, Lua. Love you for helping me out. Okay, so let's try this. All right, so I don't think... Oh, wait, some did pass. That's a start, I guess. So then here, attempt to perform arithmetic on a nil value. So that's not cool. Field question mark. Which one's actually passed? Attempt to perform arithmetic on a nil value field question mark. Okay, so Lua print. So we just print. Okay, so let's say. Okay, let me do a couple things. Let's say span equals config span. And then let's replace. Okay, so then let's say digits equals config digits. And then do the same thing. Config digits. So we'll go ahead and replace. So now I just have config these places. Okay, so now print span, print digits. Let's just try it like that. So did they get printed? Oh yes, they did. Okay. Yeah, those look fine. But I still have nil value. I have 1, 2, 3, 4, A5. So that's a problem, but I don't think we're there just yet. Actually, that's one of... Okay, so the edge cases are actually succeeding apparently automatically. Thanks, Lua. Thank you so much, Lua, for doing that. All right. So then this one. All right. So let's try printing something. So first is digits sub I, or sub 1 to begin with. Okay, so then... E equals digits sub I. And then let's use E here. Oops. And let's print E. Which should be a lot. Let's see. But it's not. That's messed up. I don't see E's coming out. no, not end. It should be, len. You know, I'm not sure I can index on a string the way I was trying to do. So string library, sub. You know what? I don't think I can index on a string the way I was trying to do. I think I have to use sub. Yeah, let's change that. Okay, so where do I have square brackets? Right here. So digits is supposed to be a string. So the expectation then is that we won't be able to do that. Instead, I think we have to do string.sub, right? Like they did here. String sub digits as the string. And then here we put I, and here we put 1. Okay, so then next. Okay, so that's the same thing. So this should be string sub digits 1, 1. Okay. Here again, yep. String sub digits I1. And then yeah, this is the last place it looks like. So here it should be string sub digits. We'll put that number, and then still just 4 successes. Did I get any more prints? Okay, so this is fine. I got 5 for a product, but that doesn't seem good at all. Okay, let me get rid of some of these. Let me just focus on that one. Okay, so 0, 5, 2. Yeah, that's no good at all. So it should be running function now. All right, so then this, I'm trying to go I1 span do, but we can't do it, I don't think. We'll execute something for each value of var from exp1 to exp2, using exp3 as the step, but exp2 in my case I think is the one that's not working, and I think because it's a string. So let's look at the coercion. So provide some automatic conversions. Let's see, when a number, okay. All right. What about not automatic? So coercion here, conventions, adjustment. Okay, let's see. Okay, so I'm just gonna say that because I do need this to be a number, I'm gonna say +0, thinking that that will make it more of a number than it was. So let's see if that makes any difference. No. Darn. Okay, so for this, do... Alright, so this +0 didn't help. Let's just get rid of it. Hmm. Okay, so we had 2. I don't like it. I don't like it. I don't like it. Hmm. Or do something end. Hmm. Okay, let's try this other. So what if we say I equals 1 while I less than equals span do I equals I plus 1, right? Should be, I guess, the same, I would think. Oh no. Okay, automatic conversion. So this is what I was hoping to see happen, right? Automatic conversion between number and string at runtime. Any numeric operation applied to a string tries to convert the string to a number. Um, okay, let's do 2 number. So this should always be 2 number. We don't want that as a string ever. This will still be a string, but here where we do this, it's going to be 2 number. Uh, what? Huh. That's weird. Well, it looks right now, but what if I get rid of the prints? Uh-oh. What? No way. Do I need parentheses or something? It didn't show them, did it? If it did, I'm dumb. Lua while loop. Okay. Okay, okay. Something was really bizarre there. No. Shoot. Are spaces here bad? No way. No, it's not that. No, not that. Huh. Lua while loop. Troubleshooting. Okay. Wait a minute. Lua less than... Oh. There's no way. Okay, so... Less than equal. That's what I've been trying to use. Shoot. Okay. This is freaking me out. Actually. Um, so does this one look better? No, it's still not good. I do not understand. Um, Lua print in loop. Okay. It says 1 here. Function. Something is very wrong, I think. Hold on. Local school. Oh man. Wait, what was the two number? What two number? Okay. I actually do not have any idea what's happening right now. Gosh. So why do I never get to bottom? I only have returned the one place. Except up here, I guess. Okay, so for do end. Okay. I have badly misunderstood something. Okay, so we don't get to looping again. We don't get to there. First, max, len. Is there, wait, is there a runtime error being suppressed or something? Okay, so there is a runtime error that I haven't been understanding, right? It's on Lua 8. So this is where I should have been putting my attention, right? And I wasn't. Because I didn't understand it. Okay, so arithmetic on a nil value. Oh my gosh. Okay, so I was doing sub wrong. All right, error. 13. Okay, so string length. Oh, it's len. What the? I was stuck on, and it was telling me the whole time, and I was like, what is happening? What is happening? Okay. And then I saw, I'm not doing well today. Let's at least finish this. Okay. Okay, span. I guess so. I think so. So we were supposed to use len here. Okay, well, I think I'm much closer. Now I just have to fix whatever I've actually done wrong. 8 successes, 5 failures. All right, so passed in and expected 72. So this was largest product of 2 with ordered digits. Okay. Okay, so this one's super long. Can we get past it? Not sure how to disable the test. Probably just comment it out, right? Okay, so 1 0 2 7 8 3 9. Yeah, that looks right. 0 1 2 3 4 5 6. Well, you know, it looks like I'm probably not quite going far enough. If only I could scroll up with the keyboard. I should just... Okay, hold on. Yeah, let's comment out that test. Did I already look at this? Why does it keep doing... I never, ever want it to autofill like that. Alright, so... Yeah. Alright, so the span was 2. So should first have been 8 at some point. I'm not sure. I don't think so. I think I might be okay there. so we print the first here. Yeah, I don't think it needed to be printed. Okay. And first is a number, right? Always? Okay. Oh no! Okay. Oh no, that should be fine. Product times E divide first. Okay, so this will not work. Here we have to redo it, right? I was so down in the weeds in the most ridiculous way. Okay. So this can't work. So here I has to be first index. Let's make this one J. Now I got larger than expected. 12, okay, so the 12 successes. Lua command line source code formatting. Oh man, what a day. Do we want this, or is this pretty standard? Lua rocks. I'm using 74% hard drive. I ordered another hard drive. I ordered a 5 terabyte hard drive to add to my build. A cheap one, but 5 terabyte, that's, I mean, it wasn't that cheap. It was like 150 or something like that. So, all right, let's try that. Seven 18 stars. Uh-oh. So I already configured the authenticator app, so I don't know what they're worried about. What the? This is slow as heck. We're having to build a CPP? Oh no. Oh no. This was not a good idea. Okay, let me open another one. Okay, I think that's a little better. And then Oh no. It tells me where it's at, right? It's at 25 and 27. Should be using Git for these probably. Oh, I don't have return here. How dumb. Oh, again. One plus I minus span. This seems goofy. Isn't this just I? Yeah. Okay, that's nice. That was goofy. We're like, what? Hello? So I already had one. Oh my goodness. Oh, wait, wait, wait. Oh, no, I didn't. So what did they have it do? They said Lua rocks. Okay. Okay, fair enough. I have work in the morning. I am gonna stop now. Got just about nothing done. Actually, you know what? Got Advent of Code done, and that didn't go too badly. It was a fairly easy one, you know. Let me review that one again. Just real quick. So there's kind of a decent amount here. Like, this is the main thing, right? So really, yeah, it is just a very easy sort of tree pathfinding. I feel like it does sort of draw upon like having seen such algorithms before, I guess, but it's quite a simple example. So that one wasn't too bad. Okay, I am gonna stop. Have a good night and see you tomorrow in the afternoon. So what I'm gonna do in the afternoon is I get off work at 4. I'll come